All right, rationalizing the denominator. So, when you have radicals being divided, we never leave a radical in the denominator. So, in order to cancel it, we do something called rationalizing. So, let's start with number 1. If you have the square root of 25 over 3. Now, the first thing you should look for is to see, can I reduce? That's the number one thing. Can you reduce? If you cannot reduce, let me write that down so you know. First, can I reduce? That's the first thing you look for. If you cannot reduce, the second thing you look for is this. Are there any perfect squares? If there are no perfect squares, then you go to the third step. So it's a 3-step process. Let's begin. First, can I reduce? 25 and 3. No. So, second step. Are there any perfect squares in either of these numbers? Yes. The square root of 25 is 5. So, this gives me 5 over radical 3. Which leads me to my third step, rationalize the denominator. So, multiply the top and bottom by radical 3. So with that final answer, I get 5 radical 3 over 3. At the end, make one last check to see that the number on the outside cannot reduce with the number underneath. 5 and 3 cannot reduce, you're finished. That's the answer. Number 2. For number 2, we have square root of 24 over 16. So again, start with your steps. Reduce first. I understand that the 16 is a perfect square. But when you reduce first, you give yourself smaller numbers to work with, which make the other steps much easier to perform. So always start with this first, reduce first if you can. The only time you would not reduce first is if both numbers were perfect squares. If both numbers are perfect squares, then just take the square root. But if only one number is a perfect square, it is easier to reduce first. So let's do that. Both of these can be divided by 8. This will give me the square root of 3 over 2. From there, now, are there any perfect squares I can pull out? Neither of these are a perfect square. Neither of these have perfect squares in them. Therefore, I move to the next step, rationalize the denominator. Times radical 3 times radical 3. So for my final answer, I will get the square root. Let's change that part right there. Times radical 2. Times radical 2. My mistake. This will give me radical 6 over 2. Number 3. Square root of 49 over 14. Again, I understand 49 is a perfect square, but do this first and it will make it easier. Can we reduce? Yes, we can. Both of these can be divided by 7. This gives me the square root of 7 over 2. Now, are there any perfect squares inside here? No. Neither of these numbers have a perfect square inside them. So, Third step, rationalize the denominator. Times radical 2 times radical 2. This gives us the square root of 14 over 2. We radical 7 over radical 6. Again, can I reduce? No. Are there any perfect squares inside 7 or 6? No. So, go to the third step, rationalize the denominator. Times radical 6 times radical 6. On the top, I will get 3 radical 42 all over 6. Once I have rationalized the denominator, look at the numbers on the outsides. Can you reduce those? Yes, you can. This cancels, this becomes a 2. So my final answer is just the square root of 42 all over 2. The 42 cannot be simplified further. As long as you first reduce everything that can be reduced, and then second, pull out any perfect squares that are still inside the radicals, and then rationalize the denominator, as long as you follow these 3 steps, the number you have inside the radical on top will not have any perfect squares left inside it, as long as you did these first, okay? That's why I'm giving you these steps. Do these 2 steps first before rationalizing the denominator, and this number up top will not have any perfect squares left inside it. You can leave it. Number 5. 10 over square root of 15. All right. Can I reduce? No. The 10 is outside the radical, the 15 is inside the radical. You cannot reduce the outside with the inside. Step 2. Are there any perfect squares? No. So just go ahead and rationalize. Multiply the top by the square root of 15 and the bottom by the square root of 15. From there, I get 10 radical 15 all over 15. And do one last check. Can I reduce? Yes, I can. This becomes a 2, this becomes a 3. So, for my final answer, I get 2 square root of 15 all over 3.